Hey Karan,
Hi Akshay, am I audible?
yeah Karan, you're really clear. So how are you?
Doing good. Thanks for having me out here.
Yeah, it's a pleasure to have you like here as well, and it was pleasure having you last time as well. So Karan, like could you go ahead and give our audience a quick introduction, who you are, like what you do, and what your session is going to be about?
Right, sure. Akshay, can you just bring my screen also as well?
Sure, yeah, sure, Karan, yeah, sure. I've added your screen and I'm removing myself from the stream.
Great. All right. Good morning, everyone. And for those of you who might be tuning in from outside of India, good afternoon, evening as well. So I'm Karan, and I manage developer relations for GitHub in India. And before I dive a little more into what I do, I want to give a quick sneak peek on the session that I'll be doing, which will be CI/CD with GitHub Actions and Kubernetes. So in the previous session, you saw Vivek talk about Kubernetes and also the basics and how to get started with deployments, etc. And what I'll be doing in this session is I'll be taking it a step further to talk a little more about how you can actually set up continuous integration, continuous delivery, using actions all right within GitHub, and along with Kubernetes as your target. So so let's get started. So a quick intro. So I'm Karan, and I'm a lot into developer relations, communities, cloud, DevOps, and open source. And when I'm not doing any of these things, you can see me reading a lot of books, and then doing a little more of on screen off stage work, and then learning more about it, etc. So that's a little bit about me. And here at GitHub, I work on helping all of you developers grow, and contribute back to the open source ecosystem, and also help all of you in the journey towards open source, helping make the software for all of us really very better. So that's one of the things that I do. Um, so all right, so let's get started then. And firstly, for those of you who might not be aware of what is CI/CD, I want to give a very quick overview. Now, I think it's a good time, for me to call out that this session assumes that you have some basic knowledge of what is CI/CD, because I won't be covering in depth on it. It's really a huge area and a lot of nuances for you. But of course, like most of the other concepts when it comes to development and DevOps, practicing is the best. So I won't be killing you with any of a lot of the presentation, but there will be a demo where I'll be showing most of you. So so before getting started, like how I said, so what exactly is CI and CD, right? So in short, continuous integration, continuous delivery. But I know that's not what you were looking for. So think about the use case, or a scenario. For example, what Vivek had shown in the previous session, right? So you have an application that you want to deploy on Kubernetes, or pretty much anywhere that you want. And if you're working in a large team, or even a small team for that matter, 5 members, 10 members, or even 100 members, thousands of developers, etc., one of the challenges that you'll start facing is how do you manage all of this development and the deployment and the testing, the monitoring, the observability, the logging, and all of those things, right? So it won't be as easy for you to just go on your machine, connect to a Kubernetes cluster, and say I'm going to deploy this. It's great for testing. I'm not saying there's nothing wrong in that, but when you're starting to use it on production applications, having a CI/CD pipeline would be really, really useful. Now, like how I said, giving a very quick overview of how this all works is, say you have some code, an application, and for this sake, I'm just going to refer back to the application that Vivek showed. You say a voting application, right? And if there are multiple people who are working on that, all of them might be committing their code to a central repository, say on GitHub. Yeah. And there will be other dependencies as well that it might have. If you're using, say, something like Python, and you're building on top of Django or Flask, you need to collect those dependencies. If there are other front end frameworks that you're using, you need to collect the distribution version of that, and you need to bring together all the related code. Yeah. So your own code for the application, as well as related code or dependencies. It need not always be a dependency, it could be related in another way as well. Yeah. So you bring together that, and what you do in the continuous integration pipeline largely is you build all of that together, right? So basically you bring together all of your source code, you bring together your related code, etc., and make sure that your application is in a state where it is almost ready to be working and deployed. Yeah. So but before that, you have to ensure that it is of a high quality and works as expected. So that's where testing comes in. Things like your unit test, integration tests, or whatever other tests that you would want to do for your application, right? So once your application is built, you would ideally want to test it. And the ideal way to do it again is to automate most of it. So most probably your developers might be writing unit tests and integration tests, etc., using a testing framework. So if, say, for example, you're using a Python, then probably you might be using the unit test framework. Or if you're using Java, then maybe JUnit or whatever is the testing framework. So you write that code for the testing, and then you set it up in such a manner that all of these tests can happen in an automated manner. So that is what your CI pipeline takes care of, where once there is a certain commit and related code ready for your build, the CI pipeline does the build and then also runs all of the tests to ensure that your application is now in a reasonably usable state. That is, it's built, it's working fine, all the tests have passed. Yeah. So the CD pipeline is what would be after that. So there are different schools of thought when it comes to CD. A few of them prefer to have it as continuous delivery. Few of them want to have it as continuous deployment. Now, there is no right or wrong. It all depends on how you want to manage it and how your team is comfortable for your use case. So in a CD pipeline, what happens is, if you're talking of containers, the output of a CI pipeline must most probably might be a container image. Yeah. Along with some of the other configuration. Yeah. Maybe like Kubernetes YAML files. Yeah. So in a CD pipeline, a delivery or a deployment, what you would ideally do is you would deploy these containers or a Kubernetes manifest into different environments. Say, for example, you might have first is review. Yeah. It might not be an environment, but probably just a manual review. Yeah. And then after that, probably you can set it up in such a way that there is a manual deployment or even an automated deployment to a staging environment, wherein you're actually running your application on a staging environment which is very close to your production environment, but is not housing production data and is not being used by users externally. So you can test out how your application works in staging, and then after that you can either set up manual deployment or even an automated deployment into your production environment. Yeah. So that's a very high level, very high level overview of what this pipeline would look like. And I'll be showing you a demo of this itself on how you can use GitHub along with Kubernetes for a sample application. So before moving into that, one of the things that I wanted to touch upon, adding on top of what Vivek mentioned previously, is the advantages of using Kubernetes. Yeah. So when you start using Kubernetes for your orchestration, yeah, you have things like service discovery and load balancing taken care of, or you can manage it. Yeah. So when I say service discovery, it could be things like if you're using a microservices pattern, wherein your application consists of multiple individual services that work together. Yeah. When you have a lot of services, the discovery of these and ensuring that the services are talking to each other becomes important. And even load balancing across the multiple services. Kubernetes can help you with that. Similarly, with storage orchestration, now if you have 2 or 3 VMs or nodes on top of which you're running Kubernetes. Yeah, managing the storage will become very important, because you just cannot say that, okay, I have one VM and I'm going to store all my data just within that VM. What if that VM goes down? Or what if your application pods gets moved over to a different VM or to a different cluster altogether as well? Yeah, so you can use Kubernetes to configure the storage orchestration however that you want. And automated rollouts and rollbacks, like how in the previous session Vivek mentioned how you can use deployments to do automated rollout and rollback. That is something that Kubernetes helps you with. And one of the most important things, and this is what comes to mind when people talk about container orchestration, is automated bin packing. Yeah, so think of it almost as your resource allocation, where if you have, say, two nodes or three nodes, and you have multiple containers which needs to be deployed, and each has a different resource requirement. One of them needs a really high RAM, one of them needs a really high CPU, one of them needs a lot of network throughput, one of them needs a lot of disk IO, etc. How do you manage, how do you provision, how do you decide which container to be deployed in which node, and to ensure that it is optimized as well? So that's where an orchestration tool like Kubernetes comes in, which helps you with that automated bin packing. And also self-healing, where you can use concepts like your replica sets, deployments, etc., to ensure that you have your availability taken care of. And also when a pod comes down, or a deployment etc. is not available, you can add in necessary resources or checks to ensure that the state of the cluster heals by itself rather than your manual intervention. And of course, one other more important thing is secret and configuration management. You would have a lot of your secrets like API tokens or database passwords, and this would be very different for your staging environment, your production environment, your development environment, etc. You have to manage all of these to ensure that the production secrets are not accessible by everyone, or the configuration, say for example the database URL for each of the environment differs from environment to environment, right? So there are all of these things that you really have to orchestrate when you're managing multiple containers, and that's where something like Kubernetes comes in and helps you provide. So so before moving on, I want to give you a quick overview of what is GitHub Actions and how you can use that to orchestrate your CI/CD pipeline using Kubernetes. So I'm not sure how many of you might have already heard of GitHub Actions or even used it. So I'm going to assume that you probably just are aware of what is CI/CD, but not what is GitHub Actions. So in simple words, GitHub Actions is a world-class CI/CD tool, um, which is fully integrated with GitHub, and it can respond to any GitHub event. For example, you can trigger your pipeline, right? So pipelines usually, when it comes to CI/CD, are triggered by certain events. So say for example, the event could be timing. Run this pipeline every day, every other week, or every month, or it could be triggered based on releases, based on pull requests, etc. Right? So GitHub Actions can respond to any GitHub events like what I mentioned before. And there are thousands and thousands of community powered workflows as well, written by developers like all of you, using which you can make your automation workflows and even your pipelines a lot more efficient. And the best part is that you can use GitHub Actions for any platform, using any language, on any cloud. So there are more other advanced concepts as well, and advanced capabilities that you would have probably seen in most of the CI/CD tools. Example being matrix builds. Yeah. So a scenario wherein, say, you are having a Node.js application, and you want to ensure that your application is tested with different minor versions of Node.js. Yeah. So you would have to run certain repeatable tasks for every version of Node.js. Yeah. So that's where things like matrix builds will really help you define a matrix of how you want all of this to run. And there are also streaming and searchable and linkable logs. so that you can share this with your teammates, etc. If there is something that's gone wrong in a certain place of your workflow. There's a built-in secret store as well, which I'm going to show you a demo of. It's very easy to write and easy to share. It's all YAML, So if you think about it, Kubernetes manifest files are all YAML, and GitHub action files are also all about YAML. So let's deep dive into what some of these workflows are going to look like, and how you can actually compose your pipeline using actions. And then I'm going to show you a demo of this itself. So an example is that one of the things I mentioned is GitHub Actions is one of the world-class CI/CD tool, but you don't have to use it just for CI/CD. That's the beauty of GitHub Actions, because you can set up any workflows. It could be things like responding to pull requests, responding to comments, opening issues, closing issues, adding labels. You can automate all of these workflows as well. And you can again use the millions of open source libraries to create your own actions, and you can write your own actions in JavaScript, or even write a container action. That is a slightly out of the scope of this session because we are focusing more on CI/CD, but it is possible if you don't find an action that's already there or doesn't fit your use case, you can go and write one of yours as well. So like how I mentioned, there are live logs. On the right, you can see, there is a workflow which runs, and you have logs with line numbers that you can link out as well. And they're very neatly formatted, for readability. So you can even set up checks. For example, in this case, if when someone is created a pull request, you can even set up checks saying that, okay, for pull requests, all of these checks have to pass, and only then you will have the ability to merge this pull request. So this is used by a whole lot of developers, teams, and open source applications that you would see. They have, for example, mandatory checks like tests have to pass or build has to pass, and sometimes even optional tests like there has to be linting that has to get passed, etc. So it really helps make things easier for you. So let's take a look at what a typical workflow would look like on actions for a CI/CD pipeline. So there are multiple components over here. So first thing that you can see is it's all YAML. Yeah. So all of these actions live in independent repositories. Yeah. So when I say actions, it means a certain packaging of tasks. Yeah. So, and you can see where there is number one cursor. These are all written in JavaScript using Node 12. There's a toolkit as well, like how I mentioned. Or in 2, you can use a Docker file as well to run these actions. So workflows are the main concept. So workflows are kind of like the glue which bring together all the existing actions. So if you were to look at the hierarchy for your pipeline, there is a workflow or even multiple workflows, and workflows have independent actions. They're composed of actions. Yeah. So and each workflow listens for particular triggers. Like one in what you can see, there is a push. Yeah. So that means every time someone pushes to the repository, the workflow will get triggered, and the pipeline, whatever you've written after that, will run. You can use things like shell scripts as well. You can run shell scripts for your workflows, like how you can see where there is an arrow of 2 that's pointing. It's running just a remove command of a YAML file. Or you can use pre-existing actions as well, where you can see in 3, where it's using a pre-existing community built action. Yeah. And all of these actions or all of these workflows run in virtual machines, which can be Linux, Windows, or even Mac. Now the best part is you don't have to manage all of these virtual machines. Yeah, you can if you want to. I'll come to that later, but all of this is managed on GitHub's end for you, so you don't have to worry about spinning up the VM, spinning down the VM, and all of those associated nuances that comes with managing the VMs. But I'm telling you this because this is how it runs in the backend, and you have to define which virtual machine you want to run these builds on top of. So the stuff to keep in mind regarding workflows is events kick off the workflow, and jobs run each in their own virtual machine. So a workflow file can have multiple jobs, yeah, and each job runs in their own VM, and it runs all in parallel unless you specify otherwise. And in a job is where you specify which VM you want this job to run on. And there are steps again which run in the same virtual machine. So you have a workflow, you have a job, and then you have steps. And all of them share the same file system. And then you have the logs. You can even share the artifacts within, within the workflows and multiple workflow runs as well. So here is an example of what a basic Java plus Maven CI workflow would look like. So just look at the structure. You can see that it's a single job with the name called build. And it has 5 steps. The 5 dashes, which is your, YAML list syntax. So the first one, and you can see this directly runs on Ubuntu. You're mentioning that run on Ubuntu hyphen latest, whatever is the latest, release of Ubuntu. The stable one, the latest tag to be specific, is what will be used to spin up this. You can see checkout is separate. So what happens is that when this workflow gets triggered, the first thing that you would want is to bring in your source code, because you're doing a lot of your building and testing based on your source code itself, right? So you check out those files. That's a separate action. And then after that, there are setup actions as well. So think of setup actions as some of those basic things that you would want to do before you do anything else. As an example, here in setup Java, you would want to have your JDK setup. Or if you are running a setup for your Node application, you would want to have Node and npm installed and set up and ready. So remember, this will be just a plain vanilla, say Ubuntu machine. So whatever dependencies that you have, you need to install that yourself within the workflow. But it's usually simple using setup actions. And then you can see Maven is run by a shell, using the mvn command. And then there is also an artifact which can be uploaded separately. So when it comes to triggers, basically what triggers your CI/CD pipeline? There are multiple triggers. So there is a complete documentation for the various types of triggers. I want to go into that, but you can see you can listen for multiple events, listen for a push and a pull request and a comment or a commit or an issue. You can listen for all of them together. Can even qualify them as needed. So for on create, only when tags are created, run this. You can even run for a branch. So when there is a push only for a specific branch, or you can mention a regex as well when it matches that. And then also you can schedule all of these with a cron. So you have a nightly build, or a nightly linting for all of your code. You can schedule that with a cron syntax. So like how I said, steps is where all the magic happens. So you can run other actions, you can schedule other actions, you can Okay, sorry. I guess my screen dropped off for a moment. I won't be covering more of the arguments in detail, but I'll show you that in the demo. You can even use conditionals and expressions. So you can say if it's a failure, you can say
Yes, Karan, you are live now. Are you able to hear us?
Yes, yes. Can you share the screen, please? I think
Yes, sure,
something
Karan.
went wrong with StreamYard and it suddenly kicked me out.
Okay, that sounds surprising. All
Yeah.
right, so
Uh,
adding your screen to the stream.
yes.
All right, Karan, you are live.
All right. So let's get started with the demo. Don't want to push this out further, so I'll show you a demo of how you can get started with actions. The first thing is, if you want to check out some of the existing actions, you can visit the marketplace, github.com/marketplace, and look for actions. There are multiple actions that you can reuse. So let's jump in and let's spend more time in the demo right now with some of this basic understanding. So the demo that I'm going to be showing you is a nice small 2048 application. It's a simple HTML, CSS, JavaScript game. It's open source under the MIT license, and for this specific demo, I've Dockerized it. So let's jump into it. Um, so I'm gonna show this to you probably later on. Okay, so I have a Kubernetes cluster that's already running, and I'm going to be showing you this one on top of it. So right now I'm running it on Azure, but you can use it pretty much for any Kubernetes cluster, anywhere. So my cluster is called GitHub Demo, and what I've done is I have already deployed um, a version of this 2048 game. You can see this is my repo where I am having my 2048 game. So let me show you. So if I go into this, um, so in my services and ingresses, there is a load balancer that I have added to the front end of my application called game-2048, and that is accessible through this external IP address. So let me open it up, and you can see that here is my game that's already running. So I did not show you the deployment of this because that's something that Vivek covered in the previous session. So what I'm going to be showing is how do you run your pipeline and how do you kind of continuously deploy. Yeah. So before that, let me show you what the YAML for this looks like. So let me connect to my code space so that I can show you what this looks like. So code spaces is one of the really cool features on GitHub, which helps you have a whole development environment by itself. That is integrated with Visual Studio Code on your browser editor. It all runs within a container on top of GitHub. So let me see if I can improve this. Okay, cool. So what I'm gonna do is let me just close this and then let me close bring down the terminal. Okay, so you can see I have my YAML file over here, which is 2048.yaml, and this is my Kubernetes configuration. Yeah, so so you can see that um, basically what I've done is there are two objects of Kubernetes within the same file. One is a deployment for my application, and then one is a service. So deployment is what actually runs these pods in the application, and service essentially helps me expose my deployment to the outside world so that you can access it. It doesn't have to be always exposed to the outside world, but in this case, that's how we're doing it. So you can see here it's a kind called deployment, which means it's a deployment object. The name of the deployment is 2048 app. So the specification for this deployment is two replicas, which means it's going to run two pods, and the deployment strategy is a rolling update. So basically that means that, excuse me, excuse me. So whenever you create a new or update the deployment, how should the strategy to update that should be? So two of the most used strategies are rolling update, wherein each of the pod is brought down along with a new pod being created of the new version, and then that way all of the pods within the deployment get updated. And the second one is recreate, which basically means it recreates all of the pods. So in this case we're saying rolling update. And so there are some configurations that you can add for specifically rolling update, which basically is how many maximum new pods can be created at a time, and how many can be unavailable, etc. And here these are selectors which basically says what pods should be a part of this deployment. And this is the pod definition itself, which again basically says use this label called app2048. And within this pod there's only one container, which is called 2048 game. And this is the image for this is on my GitHub account, on GitHub container registry, which is GHCR MV current 2048. And I'm saying expose the container port of 80. So this will have my deployment with two pods. And then also I have a service with a name, a selector which says uh, what what pods should be exposed to this service. And here I'm saying app 2048, which is the same as what it is for my pod as well as my deployment, because that's what I want to expose to the outside world. It's a type of load balancer. There are different types of services, but when you mention type load balancer, the underlying, if it's a cloud provider where you're running Kubernetes, in this case, for example, Azure, will be creating a new load balancer and attaching that to the service. So I'm just adding a name, an HTTP, the the port number of the service itself. So in this case, you can think of it as the port number of the load balancer and the target port. So where should traffic coming to this service be redirected to, on which port? Where we know because we're mentioning the pods with app 2048, but which port? So we are saying port 80 because that is what we are specifying for the container port as well for our specific application. So this is a simple a manifest, Kubernetes manifest that has already been deployed. So let me show you that using the kubectl command. So we're gonna increase this font size. So like how Vivek mentioned in the previous session, kubectl is the command line client, kubectl, kubectl, however you want to call it as, to interact with the API server of your Kubernetes cluster. So I like to usually create an alias just called k, uh, because k for Kubernetes, k for Karan, and then use that. So I'm just going to do a k get nodes, and it's going to show me the nodes, that is in this case the virtual machine. So you can see I have two nodes which is running as a part of my cluster. So since I've already deployed this, the demo which I'm going to be showing you is how to update this and ensure the pipeline runs. Yeah. So if you're thinking that, hey, why are you showing us already a deployed application, don't worry, I'm going to be deploying it again through a pipeline and showing it to you. So let me show you that. So if I just do k get deploy, it's going to show me all the deployments. So you can see that the deployment is 2048 app, the name which I mentioned over here. And both the replicas are ready and available, and it's been running for quite a while now. So let me also just see services, k get svc or service, etc. So you can see the service called game-2048, which is what I defined over here, of type load balancer. And this is the IP, cluster IP for the service that's within the cluster, it's accessible. And here is my external IP, so this is the IP address of the load balancer that can be used to access the application. So let me copy this and open up the application. So if I open up this, like how I said, I can see my application. Yeah. So let's now take a look at our pipeline itself, our workflow file that we are going to use to deploy. So you can see that there is the 2048.yaml here as well. So workflow files for GitHub Actions are within the folder called .github and /workflows, and it's a YAML file again. Yeah. So like how you see over here, it's all YAML. So let me collapse a few just to show you the structure. So you can see there is a name for the workflow called deploy to Kubernetes cluster. There is an on, which means the trigger. So in this case, I'm saying when there is a push of tags with v star. So this is a regular expression. So I'm saying any tag which starts with a v, trigger this workflow based on that. So the jobs is where there's going to be the pipeline that's going to be running. So let me collapse this and show you the jobs. So you can see there are two jobs over here. One called build, which builds a new container image based on the tag release, and one is called deploy. So let's take a look at what build does. So you can see the name is called build, and it runs on Ubuntu-latest. So a job is composed of steps, like how I mentioned. So what are the steps to run this job? So just remember, the build job will run in its own VM on Ubuntu. The deploy job also will run in its own VM. Okay. But we would want the deploy job to run only after the build job is done. Yeah. So we didn't want build and deploy to happen simultaneously. Otherwise, you'll still end up deploying an older version of your application, right? So we'll see how that is accomplished. But right now, the build job, the first thing is I'm checking out all the files. It uses an action called checkout, and by default, it checks out the files within the same reference that triggered this workflow. Okay, so by reference, I mean all the files within the commit related to the tag, within the branch, within a pull request, within a commit, etc. Right. So that is by default, but you can change the behavior. And here, what I'm doing is I'm using a community built action. This is the name of it, where this action pushes the image, it builds as well as pushes the image to my container registry on GitHub. So what I'm saying is, for it is with is basically how you pass certain arguments to the action. So I'm saying the name of my image is mvkaran/2048. The registry is GitHub container registry, and the Docker file is Docker file here, which you can see within the root of my repository. And then remember I mentioned to you about secrets. Yeah. So where I say this is the username for the registry, and this is the password for the registry. Notice how I'm not mentioning my username and password over here. So these are resolved um, uh, through context. Yeah. So here there is a context variable that's available within workflows called GitHub, and .actor basically gives you the username of whoever has triggered this workflow. Yeah, and where it's running. And then the password is I'm using the secret store, and then I'm mentioning look for the name of the secret called pat, which is personal access token. So where you can find this within GitHub, if you go into settings for a repository, you can find secrets here towards the left. So if I go into secrets, I can have multiple secrets over here, and that's where I have my pat. So I'm gonna go back again over here to my code space. So it's gonna use that and then push it and have it on the container registry. So let me open up my um, my container registry. So if I go to my packages on my profile, I can see 2048 over here, and I can see the recent image versions and all of that. I pushed one image last night, and that's what's available on my container registry mv current slash 2048. Yeah. So, and then once the build happens, we want the deploy job to run. Now, I haven't included test over here, but it would be very similar. So you can have in between build and the deploy job, you can have a test job. Now, just remember the order doesn't really matter in the which how you kind of write it down. You can resolve the dependencies through something called needs. Yeah. So this is how we are resolving the dependencies within jobs. So we have a deploy job and we say needs build. That means the build job should be completed before the deploy job starts. Yeah. So and then this also runs on Ubuntu latest. Now just take a closer look at what's going to happen with deploy. So the first is we are of course doing a checkout. This need not be the case always, but I'll tell you why we are doing a checkout. The second is we need to set the context from kubeconfig, right? So basically, what we're going to be doing is we need to first establish a connection with our Kubernetes cluster, right? So there is an action, that Azure has written, which is Azure slash k set context v1. Now this is something that you can use for any Kubernetes cluster. Basically, what you have to do is there are multiple methods available of how you can set the context for interacting with a Kubernetes cluster later on. So one of them is called kubeconfig. For this, what you do is you just pass a kubeconfig file. Now, what is a kubeconfig file? Basically, has all the configuration options for connecting to a certain Kubernetes cluster. So if I do kubectl config view, it will show me multiple things like what is the cluster, what's the name of the cluster, where is the server available, what is the certificate authority, and all of this. Again, it's a basic YAML file. Yeah. So I have again added that to my secret store and mentioning that, and I'm mentioning that the context is GitHub-demo, which is my Kubernetes cluster. So I set the context saying, okay, anything that I'm going to be mentioning about Kubernetes later on should use this context. So next, what I'm going to do is I'm going to get the tag name. Yeah. So why do I need the tag name? Well, what I'm doing in this case is I'm getting the tag name of whatever triggered the pipeline deployment and use that as the same tag for my container. Yeah. So here you can see the tag is v3.1.0. Yeah. So if I do a new tag of say v3.2.0, I want my container image also to have the same tag. Yeah. So that is the reason why I'm getting that tag name through this again community action. Now I'm getting the new container image tag. So basically I'm kind of like building that whole URL very similar to this ghcr slash io slash blah blah blah. So that's what I'm building it over here, where I'm using something called as a set output, which gives an output which can be referred later on. So I'm saying ghcr.io slash mvcurrent 2048 and get tag name. So this is an environment variable get tag name that is set by the previous action over here. Yeah. So then after that, finally, what I'm going to do is I'm going to deploy to Kubernetes. So again, I'm using one of the actions written by Azure, where I'm mentioning that which is the manifest that I want to deploy. There can be multiple manifests that I can mention as well. And what is the images that has to be updated. So here I'm mentioning, again, a variable, which basically means, okay, in the steps in this job, there should be an ID of a step called image tag. You can see over here. And then the output of that step and with the name called image you can see over here, right? So basically it gets that whole URL and says update this. Yeah. So that's what's going to happen when I run this workflow. Yeah. So there's a job, there's going to be a build that happens, there's going to be a deploy that happens, and then it's going to run, right? So let's do that right away. Yeah. So what I'm going to do is again, you don't have to necessarily use a code space itself. You can do it in any other way using your git terminal or however you want. So this I'm going to show it to you. For example, I'm just going to go to index.html and I'm going to just edit it right over here only. You can do this anywhere that you want. So you see there is a text over here called join the tiles and get to 2048. Yeah. So I'm just going to update this one, very simple update, just to show you how the pipeline is going to run. So I'm going to say, um, just say, hope you are excited at OSS days. Okay, a very simple update. I'm just changing that text, but it pretty much holds true for anything. Yeah. So and then I'm gonna directly commit it right over here to master. um so okay, so you can see that this has been updated, line 30. So now let me go and check in actions. This wouldn't have triggered anything because remember, we are triggering the workflow only through the push of a tag which starts with V. Yeah. So let's go create that. So what I like to do is usually I like to um, create a new release. So just for reference, this is the tag. So I'm going to say create a new release, and um, I'm gonna tag this as v 3.2 point, sorry, 3.2.2. Okay, and I'm gonna say OSS days release. Okay, just the name of the release. So it's gonna create this tag with a target of master, and then I can even attach the binaries that you want. It doesn't really matter. So and I'm gonna say publish the release. Yeah. So um, so if I go back, you can see it's related to the commit that I just had pushed. And let me go back to my actions right now. You can see there is a new workflow which is running. So if I go and click on the name, there is one in progress job. And if I go and click on the left over here, it's going to show me the steps. These are the logs. So the setup of the job is complete, which means all the necessary actions have been pulled, and then it has done a checkout of the files as well, of getting everything. And now it's what it's doing is it's building and pushing the Docker images. So you can see it's it would be, so all of this, right now the build job would be running on a VM that runs Ubuntu. Yeah. So that's where all of this workflow would be happening. So let's give it a few more seconds, but meanwhile, while it's running, I'm going to show you what it's doing right now is this step, build and push Docker image within the workflow. So it's taking a little longer than usual. um, so let's give it a few more seconds. It should have been done by now. So in I talked about the streaming logs as well. So for example, if there was something with the checkout, what you can do is you can see the line numbers over here. You can actually just right click and then a copy link address, and then share it with your team. You will get a deep link for the logs as well, which is gonna link over back to that specific line. So you can see over here. Okay, so it seemed like it is just, this was not refreshing, but here when I open it again, I can see that both the jobs have run. So here I can see the build and push Docker image also got completed, um, v 3.2.0. So when I hit on refresh on my registry, I am able to see v 3.2.2 that was just published 2 minutes ago. So also the deploy job also has run. You can see the green check marks over here, which is all the steps that was part of a deploy job. So checkout happened, set context from kube config also was successful, get tag name also was successful, and then get new container image tag was successful, and then deploy to Kubernetes also was successful. So you can see that what happened when the deployment ran. So it did a rollout status it gives you. So 0 out of 2 new replicas have been updated, 1 have been updated, and then 1 is pending termination, etc. And then it said deployment successfully rolled out, and it gives you the output of the service as well. You can verify this if you want even within your Kubernetes client, that is kubectl, and there are some annotations which are added as well. So let me go back and then hit on refresh, and then you can see that this has got deployed within my Kubernetes cluster, which is reflecting over here. This is the IP address of the load balancer that I have. So if I go into k um, get deploy, it's going to show me the deployments. This is the name of the deploy. So I'm going to say k describe deploy the name of the deployment, which basically gives me all the details of the deployment. You can see that the image it is running is v3.2.0, you and then you can see that just a few minutes ago there have been certain updates that has happened to this deployment. So that's how you can use. Is a very very simple example, but even if you are using multiple containers or multiple manifest files, you can use a very similar mechanism to get your uh, deployment running. So basically, again, what we did over here was we had our 2048 source, we released a tag, and then it ran an actions workflow, which was pushed to the GitHub container registry. It updated my 2048 app deployment, which was again picked up by the game 2048 service, which was exposed through a load balancer, which we accessed. Yeah. So all of this is what happened when that just one workflow file with a simple deployment. So my final pro tips on how you can better use actions are you can use, like how I said, shell script on the runner shell. If you don't have any existing action, you can just use a run and then install anything, set up anything. Remember that your VM would be running for that specific job as long as the job is not complete. So once you install any dependencies, you can reuse it later on within the same job. You can use default environment variables like how I mentioned, GitHub Actor, GitHub repository. There are multiple ones as well. You can even trigger workflows externally, so something called as a repository dispatch. So for example, if you do a post to slash repos slash your owner, that is say mv current for GitHub, which is the repo, and then dispatches, you can even trigger a workflow from outside through a webhook, or just a post, or however you want it. So that way you don't necessarily have to use always and only GitHub events. Like also I have mentioned, you can use scheduled workflows with the cron syntax, and you can resolve dependencies across jobs. Like how I showed you, we resolved a dependency between build and deploy, where we said deploy needs a build and only then deploy can run. You can even resolve multiple dependencies. I mentioned also about conditionals. So you can run a job based on previous step exit status. If it was a failure, success, cancelled, always there are multiple conditionals that you can use. And you can use the built-in secret store as well, like how I showed you. You can store pretty much most of the secrets out there that you want. There is also migrating to GitHub Actions, and how you can use if you're using some of the existing CI tools, how you can use GitHub Actions along with it. There is also a complete hands-on learning course. So if you go to lab.github.com, there is a learning path that we have called DevOps with GitHub Actions, and this is something that you do hands-on. So we have our own GitHub training bot that keeps on looking out for what you're doing, and so you can interact using comments, pull requests, commits, etc., and it's gonna help you learn through a step-by-step kind of a hand-holding process. It's very cool. Most of us kind of help contribute to these learning paths or use it ourselves to learn a lot of the things. So it's really awesome. Do check it out. And finally, I know I mentioned earlier, but you can run all of these actions even on your own hardware for free with self-hosted runners. So by runners I mean those specific Docker images, or however you want to deploy, or even say VMs on your own hardware, right? So there are means to do that. Do check it out in docs. It's a little out of scope for this session, so I won't be covering that. And then finally, it's free for public repositories. So you can use actions for various different pipelines or various different automations, however you want, for public repositories. Also, right now, like how I mentioned, there are more than 5,000 plus actions available on the GitHub marketplace, and we're working very closely with, excuse me, various different organizations, tools, etc., to better integrate with GitHub Actions so that you get a more seamless workflow working with your various other tools, using GitHub Actions, and are not limited by any constraints. So you can go check it out, know more on github.com/features/actions, and you can get started using it. So that's it. I had for today. Thanks a lot, and then you can find me on Twitter, LinkedIn, GitHub.